In this video, we showcase the Theremin project completed in the fall of 2023 by Anthony Kwon and Jonghyeok. I will provide a detailed overview of all circuit components, explaining and demonstrating their functionalities. To begin with, I introduce two sets of oscillators and summing circuits. Oscillator 1 produces a primary periodic waveform, with its frequency adjustable through a potentiometer at the top right corner of the breadboard. Oscillator 2 generates a secondary periodic waveform, and its initial frequency is set by adjusting the potentiometer on the left side of the breadboard. Initially, both oscillators operate at the same frequency. However, the frequency of the secondary wave changes as the capacitance of an antenna connected to pin 3 of oscillator 2 is altered. This capacitance varies as a theremin player moves their hand closer to or farther away from the antenna, resulting in two distinct waveforms. Two summing circuits facilitate the utilization of the bit frequency between the two generated waveforms. Now let's move on to the buffer. Its primary function is to isolate the circuit into two parts, maintaining a consistent voltage drop at both input and output pins. The bit frequency serves as the input for the buffer, and its output is linked to the envelope detector. This arrangement ensures that the oscillators and bit frequency remain unaffected by the resistance in the circuit connected to the output pin of the buffer. Next is the envelope detector. A diode within the envelope detector conducts when the output of the buffer is positive and exceeds the turn-on voltage. This action leads to the charging phase of the capacitor. Conversely, when the output is not positive, the diode remains non-conductive, marking the moment when the capacitor discharges. The accompanying RC circuit acts as a passive low-pass filter, filtering high-frequency components and thereby minimizing high-frequency noise in the signal. Following the passive low-pass filter, the signal's amplitude undergoes amplification via an operational amplifier. On the display, the open-loop gain measures approximately 2.3 volts per volt. The theremin's volume could be adjusted by manipulating the value of the potentiometer located next to the amplifier. Then the signal passes through an active low-pass filter after going through a resistor. The active low-pass filter attenuates frequencies above the cutoff frequency and passes frequencies below it. The cutoff frequency can be controlled by the value of capacitance and resistor RF in picture. The yellow waveform represents the input signal of the active low-pass filter, while the green waveform represents the output signal. After passing through the active low-pass filter, the signal proceeds to an audio amplifier. As the output stage of the theremin lacks the capacity to supply sufficient current to drive a speaker, the audio amplifier is employed to project audio through the speaker. Finally, the amplified signal reaches a speaker, and we can enjoy the delightful theremin sound coming out from it.